Here is a real floppy disk. Inside this hard shell is a disk of flexible magnetic material. Here is a fake floppy disk. There's nothing flexible about this thing. We'll start with the humble floppy disk. This is the 3.5-inch size. These came out in the early 80s, and by the late 90s these were pretty much ubiquitous. Then in late 1997 Sony started bringing out a range of digital cameras that used floppy disk to store images. This unit currently doesn't work, but we can have a quick look at the loading mechanism and insert a floppy disk. There we go. Then in 1998, Sony released a flash-based memory storage format called MemoryStick. These were initially used in music players and in some other products as well. And by 1999, Sony had released their first digital camera that also used MemoryStick. They weren't cheap, however, compared to floppy disks. For example, the 64 megabyte stick, which came out in late 1999, cost initially $160. Because of this high cost, Sony did keep making floppy disk cameras for many years. It was during this time, when floppy disks were still a mass market item and flash-based storage was still a niche product, that the product in question appeared on the market. The technology, originally developed by a company called SmartDisk, was called FlashPath, and this was a simulated floppy disk. Different models were made to accept different formats of memory card, such as smart media cards and multimedia cards. The way these work is by using a magnetic head inside the disk that can send or receive magnetic pulses to a floppy drive head. The catch is the floppy drive head must remain stationary to keep it aligned with the simulated floppy head. There is a good article from imagingresource.com. They mention that FlashPath disks cost about $100 each, and high-capacity memory sticks cost $100 or more. They also mention that some universality was lost compared to using ordinary floppy disks. This is because for Windows and Macintosh computers, special floppy disk drivers needed to be installed. These would park the floppy drive heads in the correct spot to allow the simulated floppy disk adapter to be read and written to. Another limitation is these floppy disk adapters didn't work in all the floppy disk cameras. The basic principle being used here is the same as with cassette tape adapters. These were often used in cars when connecting things like CD players to a car stereo, which didn't have any other inputs. The difference between a floppy drive and a cassette deck is the heads are already stationary on a cassette deck. Instead, the tape moves. Hence the gears included to fool the cassette deck into thinking a tape is feeding through. It would be pretty cool to turn one of these into a self-contained MP3 player that you could just put into a cassette deck. Oh wait, MP3 cassette tapes already exist. They take a memory card, you can put them in a cassette deck and play your MP3s directly on your cassette deck. While we're here, let's have a quick peek inside this thing. I'll take these screws out. Screws are out, it's coming apart. I wonder if those gears are going to go everywhere. Yep, they are. Okay, so there's two more screws on this side that I missed. Let's get those out as well. Now let's have a look, see what I've done. The design of this adapter is pretty simple. An audio signal comes in, goes straight into the magnetic head, which generates enough of a magnetic signal, and the cassette deck thinks there's a tape going past it. Okay, with that done, let's have a look at the simulated floppy adapter. So it is powered by two button cells. There's the memory stick slot, and there's nothing here, so when the drive turns the spindle, nothing happens. The adapter head is under this section here, and on the other side they've made a soft material so a double-sided head doesn't get damaged. Now there's a notch here for the high density floppy disk detection, but there's no notch for the write protect function, so that must be taken care of in software. let's get this working. The first thing I'm going to need is a computer. I have a laptop here which I'm going to use. This machine doesn't have a floppy drive built in, so I'm going to have to add one on. And I do have a USB floppy drive, but that's not going to be any good because the driver mentions it's not compatible with USB. So instead I'm going to add the docking station. There we go. That gives me a floppy drive, and that should have a controller on the motherboard that the driver can talk to. So let's get this up and running and see what happens. Okay, the first thing I need to do is install the drivers. This is pretty simple. Here we go. Okay, I'll restart now. Okay, that looks like it installed okay. We've got a new icon here. MemoryStick monitor 1.50.1.8. I'm going to start off with a 16 megabyte memory stick to make a 16 megabyte floppy disk. And I'm first going to test the USB floppy drive. Even though it's stated it won't work, I want to see a negative before I provide you with a positive. Okay, so we've got that plugged in. I'm going to test this with an ordinary floppy disk first. Okay, I can see the floppy disk has some files on it. Let's now test the simulated disk. Disk is not formatted. Do you want to format it now? We'll do a yes and see what happens. Unable to complete the format. Alright, no surprise there. This doesn't work with USB floppy drives. We'll get rid of that. Okay, now let's use the internal floppy drive, which should have a controller chip that the driver is talking to. Let's test the drive. Floppy drive A. Yep, there are the files. Okay, here's the simulated disk. And there it goes. On the memory stick is just a single folder called Palm, and sure enough it works. I heard the head step just once, and now it can read this disk. Okay, let's up the memory capacity a little bit. I have a 64 megabyte memory stick here with Magic Gate, which is some sort of DRM, but we can ignore all that. Let's get the stick in. Okay, access floppy drive. Okay, that seems to work, and we have a blank stick. So I'm now going to copy some files onto the stick. Now we have a 64 megabyte simulated floppy disk, and it just so happens that Windows 98 install files, the floppy disk version, is 60.6 megabytes. So let's get that copying. This floppy disk version of Windows 98 is 39 floppy disk images, and they're saved into a zip folder, just over 60 megabytes. Something to realize is that this is copying at the speed that a floppy disk works at. And if we have a look there, we can see 32 minutes remaining copying 60 megabytes onto the simulated floppy disk. I'll leave that going and make sure that the whole thing works. Okay, looks like the copy was successful. We have the file on the floppy disk. I'll open the zip. MemoryStick adapter has gone to sleep. Please eject. Wait a while and reinsert to activate. Okay, there we go. There's the Windows 98 floppy disk version. The entire thing on a single simulated floppy disk of 64 megabytes. Now this adapter only works with original memory sticks, which only go up to 128 megabytes. That means this 256 megabyte MemoryStick Pro won't work in it. So we'll just run a quick test. MemoryStick error, check the MemoryStick and retry. Okay, so the 256 doesn't work. So the maximum size memory stick that this can take is 128 megabytes, because that's the largest that the original memory stick was available in. And the last thing is, I have found another non-pro memory stick here. This is a 2 banks of 128 switchable on the back using a little toggle. And this should work in this thing. And this will be the maximum amount of memory stick size that it will work with. So let's open that up. Yeah, we've got folders on here that work just fine. So that's the maximum size we can use, 128 megabytes. It's more than a zip disk. Okay, I'm keen to take this apart to see what's inside. So I'm going to be careful because I want it to work afterwards. It looks like there's a piece of metal that's just been folded around each side. So I think the plan is to just use a razor blade and start lifting this metal around. So let's be careful as we go. Okay, that's lifted. Let's try this side. I think we've got one corner off there. Alright, let's keep going. Yeah, that's going to come apart. I'll take the batteries out while I'm here. 1, 2. Looks like there might be a clip holding this corner in. So we'll focus on the other side. It's really starting to bend out of shape. I don't think anything's going to break if I keep going. There we go. We've got one side out, I think. Let's just see if we can carefully lift that off. Yep, I can see the glue in there. Just carefully pull that away. Let that glue separate. There we go. We're pretty much off now. Still got a bit of... right. Okay, so we did lose that mechanism there. Alright, we're inside. There's the pins for the memory stick reader, and I've got a circuit board which we're going to lift off. You can already see part of the magnetic head there. So I can't tell what's holding the circuit board in. Just have a peek under there. Don't really see any glue or what's holding it in. I'm going to guess that... There we go. This circuit board is really thin, which makes it slightly flexible, but also possible to break too easily. There we go. Starting to come off, so it's... it's damaged. Unfortunately, I think I have damaged it. So we can see this coil has two very fine wires going to it, and one of them is now pulled off. That may or may not be fixable. But let's keep going. There we go. So that's now all detached. We do have the problem of the magnetic head being damaged. So let's see what we can do to remove it. Okay, let's see what we've got here. Got one more, there we go. So there is some plastic injection molding holding all this together, but I've removed it all. So we can take the circuit board out now. Okay, there's the insides. We've got our MemoryStick reader input, got some passives and an IC here. There's the coil with a damaged wire, so looks like I can fix this. I'll have to unwind the coil slightly and reattach it to there. There's the button cell input and the SmartDisk company that made the product. And then we've got these ICs here. It looks like we've got an Atmel microcontroller and possibly some sort of memory. That looks like power supply circuitry right there. Okay, there's the magnetic head. Very simple. The core of the magnet extends as a metal bar over to the read-write area just under here. And there's the wire that isn't broken. The wire that is broken, there's enough of a nub just here. I doubt we can see that in the camera terribly clearly, but I've managed to scrape off the enamel, so I'll solder a extension onto that. As you can see, I've soldered a piece of wire onto there. So let's put it together. Okay. This goes in here. The coil has been reattached, so I'm just going to very carefully do a reassembly. Okay, we've got it back together and it looks like it's all reattached. So let's reassemble and do a test. Switching mechanism is in. Now let's put the plate back on. Not bad. Switch is working. Metal plate is back on. Okay. Battery's in and we'll do a test. Okay, back together. Okay, I've set the computer back up. Let's go for 64 megabytes into the floppy drive. And let's see what happens. Open my computer. 3.5-inch floppy drive. Battery is low. Writes to the memory stick will be disabled. Interesting. Okay, I was saying the battery is low, so I might change the batteries and see if that does something. Okay. Okay, batteries are replaced. Let's try now. And floppy drive. Okay, seems to have worked. Let's save onto the memory stick. Yeah, there we go. It's writing again. Instead of letting that save that whole 60 megabyte file, I might just test it with an image. Just a very quick write. Yep. Yeah, I think we can say that's working again. Okay, so there we have it. That was the simulated floppy disk, including a test, a teardown, and an unexpected repair.
Nothing beyond my control. Nothing beyond my control. Nothing beyond my control.